Welcome to The Explainer. Today, we're cracking open the case file on a whole new generation of artificial intelligence. We're talking about a specialized team of AI detectives, and they're designed to hunt down the most elusive and expensive criminals on the internet.
And if you want to know why this matters, well, let's start with the stakes. By 2025, this is the estimated annual cost of cybercrime. Now, that's not just a number, right? It's a massive global crisis that's driving this desperate need for security that's smarter, faster, and way more accurate.
So first, to really get how this new AI detective agency operates, we need to take a look at the digital crime scene and see why the traditional tools are really struggling to keep up.
For a long time, our front line of defense has been the intrusion detection system, or IDS. Just think of it like a digital alarm for a network. Its job is pretty simple. Watch all the traffic going by and, scream for help if it spots anything suspicious. It's a crucial tool for sure, but it's getting seriously overwhelmed.
And why is it getting overwhelmed? Well, it's because today's digital criminals are absolute masters of disguise. This camouflage, it creates this huge challenge that this new approach was built from the ground up to solve.
So the real problem here isn't just that attacks are happening, it's where they're happening. They aren't announcing themselves with sirens and flashing lights. No, they're hiding, perfectly camouflaged inside these massive, chaotic oceans of everyday internet traffic.
This chart really shows you the scale of that challenge. As you can see, the vast majority of network data, we're talking around 83%, is totally normal, legitimate stuff. The bad guys, they're hidden inside that tiny little sliver that's left. This whole problem is known as class imbalance, and it basically makes finding a threat like searching for a needle in a haystack. And this imbalance is precisely why the old way of doing things is failing. Using a single general-purpose AI model, it's like sending one lone detective to solve 1,000 different kinds of cases all at once. Yeah, it might be good at a few things, but like the research says, it just can't be an expert in everything. So, recognizing this weakness, researchers came up with a totally new strategy. Instead of one overworked generalist detective, they thought, why don't we build an elite specialist team? The big idea here is making a shift from a single AI trying to be a jack-of-all-trades to what's called a hybrid model. This approach doesn't rely on one hero. It strategically combines the unique strengths of different AI specialists to create a team that's way more powerful and effective. All right, let's meet the team. First up, we have LSTM, which stands for Long Short-Term Memory. Think of this AI as the profiler. It is fantastic at understanding the normal rhythm and patterns of a network over time, which makes it great at spotting when something just feels off. Its partner is Random Forest, or RF. This is the interrogator. It's incredibly good at making tough calls and classifying data, especially in those messy, imbalanced crime scenes we were just talking about. So, how does this specialist team actually work together? Well, it's not a free-for-all. It's a highly structured three-step investigation that's designed to maximize both speed and accuracy. Think of it like a really high-tech security checkpoint. In Layer 1, our profiler, LSTM, does a quick first pass. It separates the huge majority of normal traffic from anything that looks even a little bit suspicious. But here's the really clever part. In Layer 2, everything that LSTM marked as normal gets a mandatory second look from our interrogator, Random Forest. This is the double check, and it's specifically designed to catch those sophisticated threats that tried to blend in. And finally, in Layer 3, all the data that's been confirmed as a threat gets sent to another Random Forest specialist for a final analysis, which figures out exactly what kind of attack we're dealing with. Okay, the theory sounds pretty great, but does this new detective agency actually get the job done? Well, the evidence is in the results, and honestly, the numbers are pretty remarkable.
In some really tough testing against a massive, modern dataset, this was the overall accuracy rate the hybrid model hit. That is an absolutely stunning number. It just points to incredible effectiveness.
And that wasn't a fluke. I mean, look across all the key metrics: accuracy, precision, recall, F1 score. The model was consistently near perfect, scoring above 99.75% across the board. That just shows you it's a really well-balanced system that's both accurate and reliable. But, and this is a really important but, a high overall score can sometimes be a little misleading, especially with that class imbalance problem we talked about. So the real test of this system, the crucial part, is how well it does against the kinds of attacks that other models usually miss. So let's look at a specific case. infiltration attacks. These are designed to mimic normal user behavior, which makes them incredibly sneaky. An older model, a CNN, was very precise. When it flagged an attack, it was almost always right. But look at its recall, just 41%. That means it completely missed more than half of the infiltration attacks. They just sailed right on by. Now look at our new hybrid model. Its recall is over 85%. It's finding the vast majority of these super well-disguised threats. That is a game-changing improvement.
This is a huge leap forward, no doubt about it. But in the world of cybersecurity, the case file is never, ever truly closed. The fight is always evolving.
Because even this incredibly advanced model isn't foolproof. The research was really clear that some attacks, the absolute best of the best when it comes to camouflage, were still incredibly difficult to tell apart from perfectly normal, benign activity. The toughest cases are still the ones at the extremes. On one hand, you have those infiltration attacks, where some patterns are pretty much identical to what a regular user does. And on the other hand, you have things like SQL injections, which are so rare in the data. We're talking a few dozen examples among millions that the AI just doesn't have enough evidence to learn from. And this whole dynamic just reveals the central conflict of cybersecurity. We've built this phenomenal detective that can spot today's digital fingerprints. But that leads to the critical question. What happens when tomorrow's criminals learn to wear digital gloves, leaving no trace at all? This is the arms race that's going to define the future of our digital security.